This question?
I don't know. All right, question 6, I'm not going to go through because question 6 is just basically a horizontal projectile. And hopefully by this point you know how to do that. So set it up. All you're using is your x equation and your y equation. So x is v is equal to delta x over delta t, and y is equal to vit plus 1 fat squared. And you should be able to solve. The first thing you're going to solve for is the time, and then you're going to go into the other equation and solve for the speed. Okay. Yeah, 6 should be easy. Number 7, I might need to draw a little bit for number 7. Number 7 is actually a lot easier than it sounds. Basically what they're giving you in number 7 is they're launching a projectile.
Would you just do t squared divided by 2?
Yeah. Okay, they're launching a projectile at some angle. They're giving you some speed. This is all relevant information, because at this point at least, because they're not asking you to solve for anything. What they're saying is, in the absence of gravity, this object's path would look like this. Okay, straight line just flying off into space. But since gravity does act on the object, its true path assumes a parabola. Okay, that's what it's saying in the problem. What it's asking is, there is a measurement that's being made on the drawing from here to here. So like the straight line it would follow without gravity, and then the curved line it actually does follow, and it's saying this is delta H. Okay. So the shell's trajectory curves downward because of gravity, blah, blah, blah. Your task is to calculate the distance delta H in the absence of air resistance. On what does delta H depend? So in other words, what this is saying is, what affects the height that I'm going to fall when I'm falling? No, what do you say? Gravity. That's the only thing. That is the only thing that affects the change in my height. Right? Is gravity. I can fire at any angle, any speed. Right? The only thing that affects this is gravity. It's just this. And so the answer for this one is, sorry, it's a little bit more complicated than that.
It depends only on the flight.
Flight time is the other thing. Okay, so G and T.
Oh, it's like I think like if one is higher and one's lower, we draw it like different. This is 7.
So basically what this is saying is, it depends on how much time it's been in the air. So if I'm in the air a very small amount of time, my delta H is going to be small. Sorry.
Like the problem.
Yeah, if I'm in the air for a very long period of time, then my delta H is going to be big. But we can say that nothing else matters because this is a constant.
What about the initial velocity? Because
All right, good question. So Mac is asking, well, what about this initial velocity? Okay, if I fired it up at an angle, isn't that going to change delta H? It's not going to change delta H. It will change its position, though. Like if you're looking at a particular position in time, it will change that. But the amount of variance, in other words, from its straight line path is always going to be delta H. And it's just going to be depending on how much time it's spent falling. Let me see if I can draw a picture for you. Okay, so let's do this. So we're going to fire, one's going to be fired at an angle, okay, of like 30 degrees. And then the other one is going to be dropped off of a cliff, or pushed off of a cliff, right, at an angle of 0 degrees. So in this problem, the object would assume this, right? That would be, without gravity, you would do that. What it really does is this. Okay, curves. So here's delta H. In this problem, if there's no gravity, the path of the object would look like this. Just straight horizontal line. But it is also going to curve, so its real path looks like this. I don't know why my program keeps doing that. Okay, if they both spin, let's say 3 seconds falling, then this delta H is the same as this delta H. Even though this one might be further down in terms like it's closer to the ground because you launched it horizontally or something like that, they still fall the same distance from where they would be with gravity taken out of the problem. Yeah, this is initial velocity. This has an initial velocity of something. This has an initial velocity of 0 in the y direction. And if you look at your equations, basically the equation that kind of proves all of this is, let me write it. Let me do this. This is the equation that kind of proves all this. Because really, if we're looking at specifically delta y, then vi has to be thrown out. Okay, t is the thing that affects it, not vi or a, because those things aren't going to change really. And then in part 8, all you're doing is just using, to find delta h, you just use this. Because, like we said, the initial velocity doesn't affect it. So you can throw out VIT. This is 8. 7's multiple choice, this is 8. Now basically all we need to know about projectile motion is that the amount of time we fall is going to determine how far we fall. It sounds weird, like it's too easy, but that's how it works. Right? And I'm glad Mac brought up the point of the initial velocity thing, because that is something that a lot of students jump to. Is that if I fire it upwards, yes, your height is going to be different, because now it's going to curve upwards, but the amount of meters it falls from that original path is the same. You're just basically starting at a different point. Actually, you know what? I just thought about this. Okay. This might, are you still struggling to understand that now? Okay, so let's do this.
So,
all right, I'm going to draw some origin. Okay, on this one, I'm going to fire an object with a horizontal velocity. This might actually be a little better. So it's going to curve like this and fall below the origin somewhere. It goes through the Earth, for example. I don't know, something like that. Okay, so that red line stands for where it should be without gravity, right? And let's say it falls for 3 seconds, this would be delta H. Okay, so by changing the angle, I change the initial velocity in the y direction. What I'm going to do is essentially just turn this thing and face it upwards a bit. Okay, I'm just going to face it upwards a bit. Can you see how this picture and this picture are the same, just rotated at some angle?
yeah.
You see what I'm saying? This is the same thing as this. All I've done is I've taken this and twisted it a little bit. So in each picture, delta H is going to be the same.
Okay, so like, I think that's just going straight, that's like theoretically.
Yeah, if there's no gravity, that's the path it would take. Yes.
So you're trying to find like the height of between those.
Yeah, how far it falls.
Okay.
That VIT part of the equation only comes into play when you're looking at where it originated. That's why it's VI. Okay, because that will change, like obviously this is going to be some negative H number. This is going to be some positive H number. But the delta H from where it should be and where it actually is the same in each problem. Does that help? No?
I wasn't paying attention because I had to. My mom said something when you were going, so.
Awesome.
And I have to bike home, so I
Basically all I was saying is this picture and this picture are the same. You just rotate this one to get this one. So delta H is the same in each drawing. That's why the initial velocity doesn't matter. Okay. Go ahead and stop this.